So we are going to tackle 6.7, which is solving radical equations. So first of all, we need to be able to recognize a radical equation. It's visually very simple. It's simply going to be an equation that has one or more radicals. That's it. That's our radical equation. Now, we do need to be careful when we are going ahead and solving a radical equation. We need to check for all potential solutions. Okay, there may be some extraneous solutions. So why would there be an extraneous solution? Well, let's look at these two very simple examples in front of us. I just highlighted the square root of x equals 3. And if we were to solve that, the way you solve any radical equation is you take and you raise both sides of your equation to a power equal to the index. So that's why we raise both sides to the power of 2. So when we do that, then we've got our exponent equal to our index. And so then our x, or our radicand, just comes out from underneath the radical. That's our root. And that's going to be equal, in this case, to 3 squared, which is 9. Well, when we check that, when we take that 9, plug it in for that original x, we get the square root of 9 equals 3. That checks, no problem. All right, now let's go over and look at this problem on the right. We've got the square root of x is equal to a -4. And so I'm going to do the same process. I'm going to raise both sides of my equation equal to an exponent that's equal to the index. So sure enough, I've got my exponent of 2, my index of 2. So my radicand x comes out from underneath my radical. That is my root. So then I've got x is equal to, when you square a -4 right here, -4 times -4 gives us a positive 16. So mathematically, it doesn't appear as if we've done anything wrong, but when I go ahead and plug 16 in to for my original x, and I take the square root of 16, that does not equal -4. So consequently, there is no solution. That's why we need to check. All right, so in order to solve equations that have one radical, okay, you're going to first isolate the radical. If there is more than one radical, just choose one of them in order to isolate. Then raise each side of the equation to a power equal to the index. That's what we were doing on those examples. Okay? Solve the resulting equation. And then you're going to check for potential solutions. All right. So let's go ahead. I'm going to let you look at those examples later. Right now, let's go ahead and dive in to this first problem. So here we are, and we've got the square root of 3q minus 2 equals 2. So our implied index is a 2. So that means I am going to raise both sides of my equation to the power of 2, because that equals my index. So on the left side of my equation, I get 3q minus 2. On the right side, I get 4. Now I just solved this equation. Add 2 to both sides, so I get 3q equals 6. Divide by 3, q is equal to 2. So now I need to check this. So I go ahead and substitute this 2 into my original equation. So that's going to be 3 times 2 minus 2 equals 2. There's my substitution. So now I've got the square root of 6 minus 2 equals 2, or the square root of 4, oopsie, equals 2, or 2 equals 2. Yeah, it all checks. All right, let's go ahead and look at this next problem. So this one is different than the one we just did because on the side that's opposite of the radical side, so my left side, x minus 5, I don't just have a single term. I have two terms, okay? I have a little expression there. So I'm going to still approach my problem exactly the same. I'm going to go ahead and I see that I have an index of 2, so I'm going to put parentheses around that x minus 5, raise it to the power of 2. Put a parentheses around my radical, raise it to the power of 2. On the left, I have a binomial squared. Remember, when you have a binomial squared, okay, so a minus b squared, that's going to give you a squared minus 2ab plus b squared. That's our approach. All right, so now I'm going to go ahead and use that in order to multiply out that x minus 5 squared. So that's going to give me x squared minus 2 times 5 times x, which is 10x, plus 5 squared is 25. So that is what I just multiplied out. That trinomial gave me a perfect square trinomial. That happens every time. All right, so now I've got on the right, this exponent cancels out with that index. It doesn't really cancel out, but you can think of it that way, okay? So mathematically, what it's really doing is if I converted that radical to a fractional exponent, you would take that radicand of 4x minus 15, and then you'd put the exponent over the index. And that 2 over 2 is 1. That's why it's equal to 4x minus 15. That's why it's equal to that radicand. Okay? Now we just solved this. So I am going to go ahead and subtract 4x, add 15. Subtract 4x, add 15. Okay? So that is going to give you x squared minus 14x plus 40 is equal to 0. Now, we all remember that when you have your highest exponent is a 2, then you have a quadratic. And in this case, it's going to be a trinomial. So I can factor that, especially because on the right, I have a 0. That's how we factor. Or, I mean, that's how we solve quadratic equations, okay? And so I'm going to go ahead. Oops, let me just move this over here. So I am looking for what can I multiply that gives me 40, but is going to add to a negative 14. I don't know. How about if I've got 4 and 10, make them both negative. There we go. So that's going to give me x minus 4, x minus 10 equals 0. So then x minus 4 equals 0, x minus 10 equals 0, x is equal to 4, x is equal to 10. There we go. If you plug a 4 in, let's just check this. Okay, so if we plug a 4 in to this, okay, we'll start here. So that would be 4 minus 5 equals the square root of 4 times 4 minus 15. Okay, 4 minus 5 is negative 1, and then 16 minus 15 is going to be 1. Well, the square root of 1 is not equal to -1. And so that means x cannot be equal to 4, or 4 is what we say as extraneous. It's not part of the solution. Let's go ahead and check 10. So if I put in a 10, 10 minus 5 equal to the square root of 4 times 10 minus 15. So that's going to be 5 is equal to 40 minus 5 is 25, or 5 equals 5. Okay, so 10 checks out. That's your only solution for this particular problem. Okay, I'm going to erase that so I have a little bit of room. All right. So when you're, just to go back on that one a little bit, when you're writing your solution, it would be x is equal to 10. You can't say that x is equal to 4 at all. Okay. Let's now solve problem number 3. All right. So for this one, I have this 2 that's out front. So the very first thing I'm going to do is I need to isolate that radical. So I'm going to divide both sides of my equation by that 2. So then I'm left with the cube root of 4x minus 5 is equal to 4. All right. So now I'm going to raise both sides of my equation to the power of 3. Because that then equals that 3, that power of 3 equals the index. So on the left, my radicand kind of falls out from underneath that radical sign. And on the right, I have 4 cubed, which is going to give me 64. I go ahead, add 5 to both sides. I get 4x is equal to 69. Divide by 4, x is equal to 69 fourths. I still need to check this, even though it's a fraction, and I know people are not a fan of fractions. I still need to check. So I have 2 times the cube root of 4 times 69 fourths minus 5, all of that is under my radical sign, equals 8. Okay, so underneath that radical, the 4's reduce. Okay, and so then I'm left with 69 minus 5, which is going to be 64. So I have 2 times the cube root of 64, which is equal to 8. Well, I know that 64 can be expressed as 4 to the third. And so, and then I also know when my exponent and my index match that I can pull out that root of 4. So I get 2 times 4 equals 8, or 8 equals 8. Okay, it checks. So that means my answer is not 8. Right here, my x value is 69 fourths. Okay. Let's look at number 4. So for question number 4, the first thing I'm going to do is subtract 60 because I need to isolate my radical. And so then I get the 4th root of 9x minus 15 is equal to negative 58. Right here, I stop, okay? Stop. It's no solution. Why? Why is it no solution? Okay, it's no solution because my index is even. And when your index is even, it cannot be equal to a negative value. Okay, your radical can't be equal to a negative. And remember, it's like that example that we very, very first started with when I had that square root of 16 equal to -4, and we couldn't do that. Okay, so there is no number that I could plug in for x that's going to give me a -58. So I'm done. Now, if your index is odd, this doesn't apply. It's only when your index is even. Okay? When your index is odd, you could potentially have your radical equal to a negative number. All right. I'm going to do one other little example here that is not on your notes, but it's an important example. So here's another example. Let's take x plus 2 raised to the 1/3 plus 5 equals 3. Okay? We haven't done anything like this, at least not today. We've done some kind of like this in earlier sections in this module. So the very first thing that we want to do is we want to take that fractional exponent, and quite honestly, I'm going to convert it to a radical. So it's going to be the cube root of x plus 2 plus 5 equals 3. Now, I'm going to go ahead and subtract 5 from both sides so that I can isolate that radical. So I get the cube root of x plus 2 equals a -2. Okay, based on the problem we just did, we need to look at that index. In this case, our index is odd. So it's okay to equal a negative. So we need to keep going with this one because that -2 there doesn't cause us to stop. It's only if the index is even that we can't have a -2. All right, so let's go ahead and keep going. So the next thing we want to do is raise both sides of our equation to a power equal to that index. So we're going to raise both sides to the power of 3. All right, so that is going to give me x plus 2 equals a -8. Because -2 times -2 times -2 times -2 gives me a -8. Okay, so now I'm going to subtract 2. I get x equals -10. If I substitute that -10 in to check my equation, let's just see what happens. So that's going to give me -10 plus 2 to the 1/3 plus 5 equals 3. Okay, so that's going to be -8, and I'm just going to change that to a radical. So the cube root of -8 plus 5 equals 3. Well, the cube root of -8 is -2. So -2 plus 5 is 3, or 3 equals 3. It all checks. That is a good solution, that -10. Okay, let's keep going. Oh, yeah. Sometimes we have radical equations that involve more than one radical. Okay, well, let me point out something. In this particular example, I have 2 radicals, but they're equal to 0. This is going to be an easy one. All right, we would just add the cube root of 5x minus 6 to both sides. That's how they get this second line here. And then you raise both sides to the power of 3, and your radicands fall out. You get this really simple equation, and you solve. You solve, and you end up with x equals 4. You check it, and you're like, yeah, it checks. Life is easy. That was not hard, okay? You could look at that in more detail. I want to look at this first example that I'm going to do here. It is not equal, this equation is not equal to 0. It is equal to a 4. Okay? That is not a 0. Clearly. All right. So what does that mean? This one, when you've got two radicals and it's not equal to 0, you're going to have to do the process twice, and it gets a little bit complicated. Not a problem. It is not beyond any of you. But, okay, don't be tired. Stay with me. Okay, let's go ahead and let's do this problem. All right, so first thing I'm going to do, I need to isolate one of the radicals. So I'm going to do that by subtracting the square root of 2 minus x from both sides. So then I'm left with the square root of x plus 6 equals 4 minus the square root of 2 minus x. So I have my radical on the left that is all by itself. Nothing added, subtracted, or multiplied by it. All right, so now what I'm going to do is I'm going to raise both sides of my equation to a power equal to that index. So on the left, that's easy. That's how we've been doing it all along. On the right, make sure that you put parentheses around that entire side, that entire right side, and raise it to the power of 2. Okay. On the left, easy peasy, okay? We're just going to get x plus 6. On the right, that is a binomial squared. And when you have a binomial squared, okay, a plus b squared, oh, actually, this one's minus. Let me go ahead and change it up here, okay? A minus b squared, that's going to give you a squared minus 2ab plus b squared. Wow. So how do I apply that to here? No problem. The 4 is your a, and your radical 2 minus x is your b. So this is going to be 4 squared minus my formula 2 times my first term of 4, and then my second term, my b, of square root of 2 minus x. Then it'd be plus my b term, which is square root 2 minus x squared. Woo. Let's simplify that. X plus 6 on the left. On the right, 16 minus 8 square root of 2 minus x plus. So, just like we were doing all along, if your exponent equals that index, those kind of cancel each other out, and then you are left with just that radicand, 2 minus x. All right, we're good. So before I start doing anything, I'm going to simplify on the left. I'm going to bring together like terms, and I'm also going to bring that minus x kind of towards the front. So I've got x plus 6 equals 16 plus 2 is 18. I'm going to bring that minus x here, and then minus 8 square root of 2 minus x. Okay, wow. So now what am I going to do? I'm going to get all of my terms over on the left. I'm going to leave my radical on the right, okay? So I'm going to go ahead, subtract 18 from both sides, add x to both sides, so that I'm left with 2x minus 12 is equal to negative 8 square root of 2 minus x. Okay, so now what am I going to do? Well, I'm going to kind of give you a little tip of the trade. If I was to divide by that negative 8, that's going to give me a fraction on the left. Not really interested in having that. So I'm just going to leave that -8 where it is. And I'm still going to, I want to get rid of that radical sign. So I'm going to do that the way I've been doing all along. I'm going to raise both sides of my equation to a power equal to that index. So that's going to be on the left, I raise it to a power of 2. On the right, I raise it to a power of 2. So that is going to give me, on the left, another binomial squared that is going to multiply out to a perfect square trinomial. So 2x raised to the power of 2 is going to give me 4x squared minus 2 times, I'm going to put 12 times 2x plus 12 squared equals, now I need to square that -8. So -8 raised to the power of 2 is going to be 64, and then times 2 minus x. Because when I take that radical and raise it to the power of 2, it just allows me to pull out that radicand. Okay, now let's just keep simplifying here. So I've got 4x squared minus, well, 2 times 12 is 24, times 2 is 48, x plus 144. Okay, equals, I'm going to go ahead and distribute. So 64 times 2 is going to be 128. And so that's going to be 128 minus 64x. So let me just bring this up here. I'm going to subtract 128 and add 64x to both sides. So when you do that, you end up with 4x squared. And then that'll be a plus 16x plus 16 is equal to 0. Lo and behold, I've got a quadratic. But I can actually do something kind of cool. I could divide everything by a greatest common factor of 4, which is going to make this quadratic easier to factor. So then I'm left with x squared plus 4x plus 4 equals 0. Okay, so now this loveliness is a perfect square trinomial. So I can bring that to a binomial squared. It's going to be x plus 2. How do I know that? I can just take the square root of x squared, which is x, the square root of 4, which is 2, multiply 2x, okay, 2 times x, and double it, gets me back to that 4x, okay? If I set that equal to 0 and solve, x is equal to -2. So if I take this -2 and plug it in, I can actually quickly check my solution. So that's going to be, so my check, it's going to be -2 plus 6 plus 2 minus -2 equals 4. So that's the square root of 4 plus the square root of 4 equals 4, which sure, 2 plus 2 equals 4. That checks out. All right. Whew. We got one more of these guys. Let's do it. All right. These are not easy, and so I don't mind doing one more example. Actually, what I would encourage you to do, pause. Hit pause, try this one on your own, and then come back and follow me. See if we get the same answer. So first thing I'm going to do is I am going to go ahead and bring the x, the square root of x plus 1 to the other side. So I get the square root of 2x plus 3 equals 1 plus the square root of x plus 1. All right. I'm going to raise both sides of my equation to a power of 2. So on the left, I have 2x plus 3. On the right, I have 1 squared plus 2 times 1 times the square root of x plus 1. Then I've got plus the square root of x plus 1 squared. Okay, so that'll be 2x plus 3 equals 1 plus 2 square root of x plus 1 plus x plus 1. Okay, I'm going to combine on the right my like terms and bring this x to the front. So on the left, I have 2x plus 3. I'm not doing anything with that yet. I'm going to add together 1 plus 1 gives me 2 plus that x, and then I've got my 2 square root of x plus 1. I'm going to bring over the 2, bring over the x. So I keep my like terms together. All right, so now I've got x plus 1 equals 2 square root of x plus 1. I am going to raise both sides of the equation to the power of 2, because that's what my index is. On the left, I have a binomial squared, which is going to give me, again, a perfect square binomial. X squared plus 2 times 1 times x plus 1 squared, which is 1, equals, I have to take the 2 and apply that power of 2. So 2 squared is 4, and that is times that radicand, x plus 1. On the left, I've got this x squared plus 2x plus 1. On the right, I'm going to distribute that 4 to give me 4x plus 4. I see that I have a quadratic on the left. In order to solve a quadratic, I need my equation to equal 0. So I'm going to subtract 4x from both sides and subtract 4 from both sides also. Bring that up a little. So then I'm left with x squared minus 2x minus 3 equals 0. All right, so this factors to x minus 3, x plus 1 equals 0. So when I set each of these equal to 0, each factor equal to 0, I get x equals 3, x equals negative 1. So I need to check my solutions. So when I check x equals 3, I put it into my original problem. So that'd be the square root of 2 times 3 plus 3 minus 3 plus 1 equals 1. So that's going to give me this first one, square root of 9 minus the square root of 4, or 3 minus 2 equals 1. That checks. 1 is equal to 1. When I do x equals negative 1, and I check that, it'll be 2 times negative 1 plus 3 minus negative 1 plus 1. All right, well, under that first radical that I'm checking here, I've got negative 2 plus 3 is the square root of 1 minus the square root of 0. So that's going to give me 1 minus 0. Sure enough, that's equal to 1. That checks. So my solution, I would say, right here, x is equal to, I use my little squiggly lines to show that I have members of my set. I have negative 1 and 3 are the two members of my solution set. There we go. All right. Oh my gosh, we did a lot. Okay. Do we have more? Oh, wow. All right. So for this one, all I'm going to do, let's go ahead and do it. If you're getting this, you can move on. I'll do this one more, okay? If you'd like to see one more example. So I've got here, first thing I'm going to do, change this to a radical. So that's going to be the square root of 3x plus 1 minus the square root of x minus 1 is equal to 2. I'm going to add the square root of x minus 1 to both sides. So the square root of 3x plus 1 equals square root. You can either put it in, actually let me be consistent and do it the way I was doing it before. 2 plus the square root of x minus 1. There we go. It wouldn't matter. You could have put the radical in front of the 2. All right. Now, I've got an index of 2. So I'm going to raise both sides to the power of 2. And so that is going to leave me with 3x plus 1 equals 2 squared plus 2 times square root of x minus 1 plus square root of x minus 1 squared. Okay, let's go ahead and simplify this. 3x plus 1. So then I've got that equal to 4 plus 4 square roots of x minus 1 plus x minus 1. So I've got 3x plus 1 equals, I'm going to bring together the 4 and the negative 1 to get 3, and I'm going to bring that x in front. So 3 plus x plus 4 square root x minus 1. Okay. Subtract 3 from both sides, subtract x from both sides. So then I'm left with 2x minus 2 equals 4 square root of x minus 1. Okay? So now I am going to raise both the sides of my equation to a power of 2. So then on the left, I have 2x squared, so which is going to give me 4x squared. 2 raised to the power of 2 is 4. Minus 2 times each of those terms, so 2 and 2x. I always put my x terms seconds. All right, equals 16 times x minus 1. I had to take this 4 and apply that power of 2. That's where the 16 came from. And then I apply that power of 2 to that radical, and my radicand slips out. Oh, know what I forgot on the left for sure as I'm looking at this? I'm getting too close to it. I forgot my b term here. So that would be right here, this 2 squared. So I need a plus 4 over there. All right, now it's good. Sorry. All right, and so let's go ahead and simplify. 4x squared minus 8x, okay, plus 4 equals 16x minus 16. Okay, let us, well, this one is a little different here. Let's go ahead and get all of our values over on the left. So I'm going to subtract 16x, subtract 16x. I'm going to add 16, add 16. So I'm left with 4x squared minus 24x plus 20 equals 0. Well, I certainly see a greatest common factor when I look at all 3 of those numbers, a greatest common factor of 4. So I'm going to go ahead and divide all of these terms in my equation by 4. And when I do that, it's just going to make this so much easier to factor. I get x squared minus 6x plus 5 is equal to 0. So then I can factor that to x minus 5 x minus 1 equals 0. X equals 5. X equals 1. Those are my solutions. I'm going to tell you, I already checked them and they both work. Just to move it on here. Okay, so now we've got two little story problems, which are kind of nice, very common types of problems. So this first one, we've got Gabriel that dropped his phone from the edge of a cliff. He heard it strike a rock and just break into smithereens at the bottom of the cliff 3 seconds after he dropped the phone. I'm glad he had the presence of mind to keep track of his time. It's important. Okay, Gabriel knows that time, which is going to be t in seconds for a free-falling object, is given by this formula. How high is the cliff? Okay, so what we're going to do here is we've got our time, which is 3. Okay, t equals 3. So I substitute a 3 in for that t. Now I've got my radical here with d over 16, okay, underneath. So I'm going to go ahead and approach this the way I've been approaching these equations all along. I'm going to raise both sides of my equation to a power equal to the index. And so that is going to give me 9 equal to d over 16. I can just multiply, okay, both sides by 16, that denominator. And that is going to give me, on the left, I get 144. That is our distance. So our distance is, or how high is the cliff? The cliff is 144. Are we talking about feet? Yes, feet. Here we go. All right. Let's look at this next problem. The velocity of a free-falling object is given by this beautiful equation, where v is measured in feet per second. G is gravity, that's 32 feet per second squared, and h is our height. So if the object strikes the ground with a velocity of 100 feet per second, okay, so let's just keep track of that. Velocity is 100 feet per second, okay? Estimate the height from which it was dropped. Okay, so we know what our velocity is. We know what our gravity is. That was given to us. That's 32 feet per second squared. Our formula is v equals the square root of 2gh. I want to figure out h. So I need that h out of that radical. All right, I can do this. So I'm going to plug in 100 for v. I'm going to plug in 32 for g, and then I'm going to figure out h. So the first thing I want to do is raise both sides of my equation to a power equal to the index. Okay, so that's going to give me 100 squared, just 10,000, equal to 2 times 32 is 64h. Okay, so this is going to be, I'm going to divide both sides by 64, and that will give us an h that is approximately 156.25 feet when we round it to the nearest hundredths place. And that one is done. All right. You are in good shape now to be able to do your homework and to be successful with it. So give it a go.